Alright, so for the next part, I'm going to use trigonometry to talk about this. I went ahead and left the answers up here. I left this section over here. I've got this section and use trig. Okay? The first thing you need to know when dealing with trigonometry, there's a handful of things you really positively 100% need to know for trigonometry. I mean, there's identities and they turn out to be helpful, especially when you move on to calculus, but three of the four things that you need to know are in the phrase SOHCAHTOA. I'm going to write SOHCAHTOA up there and then I'm going to talk about it really briefly. I'm going to need to erase it because I'm going to need that space to solve this trigonometrically. SOHCAHTOA. So SOHCAHTOA. Three of the four things you need to know about trigonometry is SOHCAHTOA. What SOHCAHTOA stands for is that the sine of an angle, and we're going to express angles as theta, is equal to the opposite over hypotenuse of that angle. Okay? Cool? And when we talk about it, I'll explain what the opposite and the hypotenuses are. I'm just going over the definition of SOHCAHTOA. The next thing is the cosine of an angle is equal to the adjacent over the hypotenuse. Okay? Cool? And then lastly, the tangent of an angle is equal to the opposite over the adjacent. Cool? That's SOHCAHTOA. Now, the really cool thing about SOHCAHTOA is there's a couple of things that have to be done. First of all, we can only be talking about a right angle. We can't be talking about an obtuse or complementary, I guess. I don't remember the other one. I know it's obtuse and less than 90 degrees. I can't remember it. Man, I should know this. Okay? Is that it has to be a right angle. There has to be at least a 90 degrees somewhere in that triangle. And that the opposite and the hypotenuse are the same values. Sine theta and theta have no units. They have no units there. So in order for that to be true, the opposite and the hypotenuse have to have the exact same units so that they cancel out. Okay? So it has to be meter, centimeter, Newton, the Tesla. It has to be the same unit. It can't be a centimeter. It can't be a Newton over a meter. It has to have the same units. So in order for this to be true, the opposite and the hypotenuse have to have the same units, and there has to be a right angle associated with it. If those are not there, if it's not a right angle, you can't use this definition. And if they don't have the same units, then you're going to have to figure out a way of converting them. Okay? Hopefully it's a simple conversion and not a very complicated one. Okay? That's the only way you can use this relationship. Cool? Now, what I'm going to do is I'm going to erase it and I'm going to use this and the quadratic equation to solve for my value for displacement and at the same time solve for my value of position. Cool? Alright, so I'm going to erase that real quick. Wonderful thing about recording, you can pause it. So I can just keep moving along, pause it, write it down in your notes, and then catch up with me. So I'm not going to talk about the block itself, I'm only going to talk about the distance the person traveled. So he traveled 10 meters in the x direction, and he traveled 10 meters in the y direction. Okay? His displacement, which I'm going to express with red, is going to be from his starting position to his final position. That is his displacement. So red is getting a little bit too much black in it. I'm going to figure out how to deal with that. Okay, that's his displacement. I'm going to just write the word displacement. Okay, that's what we're solving for. Now, magnitude, how big is that displacement? Quadratic. Okay, using Pythagorean theorem, a squared plus b squared equals c squared. Cool thing about vectors, if you multiply a vector by another vector, if they have the same components to them, if they're both forces or they're both distances or whatever, is if you multiply one by the same, or you multiply a displacement by another displacement, or a velocity by another velocity, more appropriately in this case, displacement times its own displacement, okay, that the direction disappears. It doesn't keep track of that. And if you think about it mathematically, if I have a negative x and I multiply it by a negative x, I get a positive x. My direction would have been negative, negative, but instead I end up with a positive value. It turns that vector into a scalar. So multiplication of a vector to a vector turns it back into a scalar. It loses that directional information. And that directional information is typically carried in a negative sign. Okay? Cool. So 10 meters times 10 meters plus 10 meters times 10 meters is equal to c squared. Now, I know this. You guys can do this on your calculator really quick. Just 10 times 10, well, that's 100, plus 10 times 10, which is another 100. Well, the answer turns out to be 200. The really cool thing about, and then take the square root of 200. The really cool thing about that is that I already know the answer. If you can't read that, that's the square root of 2 times 10 meters. 10 meters times 10 meters, they have the exact same side. It turns out to be root 2 times the side. Okay? It always works that way if they're the same values. If they're different values, then it's not so simple. Okay? So there's your answer. Root 2 times 10 meters. That's the size of my displacement. So I'm going to go ahead and I'm going to erase this value, and I'm going to say, look, here's another way of expressing that. It's root 2 times 10 meters. Okay? That gives me the size of it. It doesn't give me the direction. I'm going to have to go back to SOHCAHTOA to give me a direction. Okay? So first thing I have to do is I have to explain what an adjacent is, what an opposite is, and what a hypotenuse is. Okay? That's the next thing I have to explain. First one is a hypotenuse. It's the most important side. It shows up all over the place. The displacement is the hypotenuse in this case. How do I know that? Well, first of all, this line here has to be opposite of the right triangle. It can't compose the right triangle. Okay? As you can see, this side and this side make that right triangle. The hypotenuse has nothing to do with it. It's opposite of that. So that's one way of telling what the hypotenuse. The other way, which most people use, is that the hypotenuse is the longest of all three sides. Okay? No side can be longer than the hypotenuse in a right triangle. So this side right here is my hypotenuse. I'll write a little note reminding me of that. Okay? Hypotenuse. So then, if we're trying to figure out the direction, we're trying to figure out this angle right here. Okay? So when we're finding out the opposite and adjacent, we have to determine what angle we're talking about. Are we talking about this angle or are we talking about that angle? Never the 90 degrees. We know that's 90 degrees. So we're going to say, we need to know this angle because we're talking about this. We need to know that angle, not this angle, in order to give me the direction. Okay? Cool? So what I need to do is I say, well, I have my hypotenuse already determined. What's my adjacent and what's my opposite? Well, opposite is referring to the side of the triangle that's opposite that angle. I'm going to erase that and I'm going to put it in blue. Well, put it in green. Green should be able to tell the difference pretty well. Okay? The opposite of that angle. Here's the angle. Here's the side that's opposite. Nothing of this side composes that angle. Okay? So these two sides compose that angle. This is the one that does not compose that angle. So this 10 meters over here is going to be the opposite. Leaving the last one adjacent. Adjacent is always the other side. The hypotenuse is usually going to make up a side, well, always going to make up a side. It's going to make up either one of the sides here or one of the sides here. The adjacent is the side that is part of that angle that isn't the hypotenuse. So the adjacent right here makes up this angle with the hypotenuse. Okay? So it's the side that helps the hypotenuse make up this angle. That's the adjacent. So if I want to find this angle, and I was given this information and this information, I'm giving both the opposite and adjacent, I have to look back at SOHCAHTOA. Well, SOHCAHTOA tells me that tangent is opposite over adjacent. Okay? So I got opposite, I got adjacent, those were all given to me. That's why I'm using tangent. Those sides were given to me. I want to use them. Okay? Opposite, that's 10 meters, divided by 10 meters. Okay? 10 meters over 10 meters is equal to tan theta. Adjacent, opposite. So 10 meters over 10 meters. Cool. Cool thing, look at this. Meters go away. You can't have units when I'm doing this function. They have to be able to cancel. That's why I keep saying they've got to be the same value. Okay? And then 10 over 10 translates to 1. So that means I have 1 is equal to tan theta. Okay? And then from there, we do a little trick. It's actually on your calculator. We're going to say tan inverse of 1 is equal to theta. Okay? It's just a button on your calculator. You have tangent, and then you have inverse tangent. If you have a TI, you just have to change the mode and click it. Okay? So that's tan inverse of 1 is equal to theta. It turns out that that value should be 45 degrees. If you're getting something other than 45 degrees, then you're probably in radian mode, which is fine. We'll use radians when we're talking about rotational motion and in some cases simple harmonic. But if you want it in degrees, which most of us are familiar with, we're going to switch it to degree mode. Okay? Now, like I said, both answers are acceptable. If you're talking about in radians, you're talking a half pi, I do believe is what your answer is going to be. Yeah, half pi. No, not a half pi. A fourth of a pi. Oh, there's some fresh air. Well, I'm in a small room with all these lights on. It's really hot. Okay? So that's my answer. So what I end up doing, and I'm going to erase this to give myself a little more space, is that my answer turns out to be root 2 times 10 meters at 45 degrees. Okay? That turns out to be my answer for my displacement. The root 2 times 10 meters at 45 degrees. Okay? Now, it's the same answer for the position because if we've gotten the same answer, there's a couple of things that we could do to change that, but we're not going to do it today. But I wanted to leave that up there. I didn't want to change it to talk about really quick. This right here, this one that we're talking for displacement, if you're following my hand, is what's called magnitude and direction form. Okay? Gives me a magnitude, gives me a direction. This is what's referred to as component form. I don't care, typically, which way you express it. If you're taking the AP exam, that the magnitude and direction is the preferred form. That's the way they want the answers expressed. If you're doing a real-life physics problem and go on to do real physics, more than likely you're going to be expressing it in component form. It's just much easier to deal with components. And actually, the next problem will show you why it's going to be much easier to express it in component form. Okay? Thank you.